Hello, dear friends. I am Miss Neha Mahurkar. I welcome you all in this video. I have prepared this video over the chapter Coordination Compounds. I know we were taking another chapter, Halogen Derivatives, but those organic reactions cannot be explained well in this online mode. So I have decided to start the new chapter. Hope you remember the word coordination or the coordinate. This word is familiar to you in the concept of bonds. We have discussed the types of bonds in which we have seen coordinate bond. The coordinate bond is formed when both the electrons are donated by only one atom. Here you can see, I will highlight the coordinate bond between A and B. Here you can see that A carries two electron pairs and B has no electron, and that's why A is donating both the electron towards B. That is, B is electron pair acceptor and A is electron pair donor, and such formation of bond is shown by the arrow pointing from donor towards the acceptor, that is from A to B, and such bond is called as coordinate bond. Now we will see next terms like metal, ligand. Now you are familiar with the term metal, means the elements which donate electrons are called as metals, that is the electropositive species. For example, sodium, magnesium, lithium, scandium, vanadium, manganese, like this. But here the sodium and magnesium, these compounds have no relation with the our chapter coordination compounds, but the elements like scandium, vanadium, manganese, like D block elements, they are related to the coordination compounds. Now this is why so. This is because the D block elements have the vacant d orbital to accept the electron pair from the ligand. That is, in coordination compounds, metals are always electron pair acceptor. Okay. Now, what this term ligand stands for? Ligand means any species. It may be neutral or it may be negatively charged. Okay, I'll repeat. Any species which is neutral or negatively charged, which donates its electron pair towards the metal or into the vacant d orbital of metal to form the coordinate bond. Here you can see that metal is present at center and ligands are surrounding the metal, and each bond is represented with the help of arrow. That is, here it is ligand and here it is metal. So in this way the ligand is electron pair donor, and the ligands are of two types. First one is neutral, examples like water, ammonia, and negatively charged like hydroxide ion, chloride ion, bromide ion, iodide ion, etc. Here I have written metals are electron pair acceptor and ligands are electron pair donor. Now, uh, long ago we have seen the concept of acid and base, that is the species which accepts electron pair called as Lewis acid, and the species which donates electron pair called as Lewis base, and that's why metal is Lewis acid and ligand is Lewis base. Okay. Now here the next term is coordination compounds. The coordination compound or the coordination chemistry. I'll give first the introduction about coordination compounds. The coordination compounds or the coordination chemistry, it is a branch of inorganic chemistry. That is, it is studied under the head inorganic chemistry. The coordination chemistry deals with the study of coordination compounds. That is the formation of coordinate bond. As I have explained earlier, in coordination chemistry, Alfred Werner prepared a large number of coordination compounds, and that's why he is called as father of coordination chemistry. Now, what do the coordination compound stands for, or what does it mean? What does it represent? I'll explain it step by step. Naturally, there are many coordination compounds are present. For example, chlorophyll pigment in plants, which is used for photosynthesis. It is the coordination compound of magnesium. If you have seen the structure of chlorophyll, you will spot the magnesium metal at center. That is, the chlorophyll is the coordination compound of magnesium. Now, in case of, it is exception in this case, because I have said that earlier, it is only formed by 3D or D block elements, but magnesium is do not belong to D block. So it is exception here. Next example is hemoglobin, which is present in human blood. That is the red pigment, and it is the coordination compound of iron, Fe. Now we will see the coordination compound. The coordination compound contains central metal ion, that is metal present at center here. That's why it is called as central metal ion, which is surrounded by number of ligands. Here you can spot metal is at center and ligands are surrounding it. Any situation where you can observe like this, that compound will be called as coordination compounds. Okay. For example, cisplatin, which is used in the treatment of cancer. Here you can see platinum is present at center, and 2 ammonia and 2 chlorine are surrounding the platinum metal, and that's why this compound is coordination compound. Number of examples can be explained like this. I'll explain it later on. Hope you have got the idea what does the coordination compound stands for. That is, it is, or the compound which contains central metal ion or atom surrounded by number of oppositely charged ions, means negatively, or neutral molecules like water. Such compound is called coordination compound, and the bond between them is always coordinate bond. Okay. Now we will see the types of ligand. Next topic is types of ligands. Now ligands, as I have explained earlier, that there are two types, either negatively charged or neutral. It is just on the basis of charge present or not. But on the basis of number of donor atoms, means the atoms which donates electron pair, and on the basis of number of donor atoms, ligands are classified as monodentate, ambidentate and polydentate. I'll first explain monodentate ligand. Now mono means single and dentate means site to catch or site to bind. That is the ligand which have only one donor atom or one site to bind with the ligand. Such ligands are called as monodentate ligands. Here you can see Cl minus, it has only one negative charge, one donor atom, that is Cl. Hydroxide ion, negative charge is 1. Cyanide ion, only 1, that is it is monodentate. Water, only one donor atom, which is oxygen. Ammonia, only one donor atom, which is nitrogen. Now next is polydentate ligand. I'll explain this ambidentate later on. First we will see polydentate. Polydentate means the ligand which have more than one donor atoms. that is 2, 3, 4, 6, so on. So such ligands are called polydentate ligands. Here you can see bidentate. Bi means two. That is the ligand which have two donor atoms called as bidentate ligands. Here you can spot EN. EN means ethylene diamine. It is the short form. Here you can see there are two nitrogen atoms and each having one lone pair. That is there are two lone pairs, that is two donor sites, and that's why it is bidentate. Again oxalate. Here you can spot two negative charge on two oxygen atom. That is again two donor atoms. Therefore it is categorized under bidentate ligand. Next one is tridentate ligand. Again the definition will be same. The ligand which have three donor atoms in one molecule. Here you can spot this is one, this is second and third. Three nitrogen atom with each lone pair, that is three lone pairs are there, and that's why it is tridentate ligand. It is called as diethylene triamine and the short form is DINE, DIEN. I have explained its structure in detail. Next one is